Hello, and welcome to episode number 67 of the weekly, daily Google Cloud Platform podcast. It is day 3 here at Google Cloud Next, and I am Francesc and Mark, and as always, I'm here with my dear colleague today, Mark Mandel. Hey Mark, how are you doing?
I'm good. It's my birthday.
Oh, that's awful. I said I was going to say it before he said it. Okay, so yeah, happy birthday, Mark, from me and all the people that we interviewed. And there's actually a lot of people that came just to say happy birthday.
That's true.
And I'm going to say that if you're listening to this episode, you should definitely tweet at Neurotic and say happy birthday, Neurotic.
Thank you so much.
All of that. He appreciates dogs, so you can take pictures of like cute dogs. He'll be happy.
Actually, I will. That's great.
I know. Today, we are very lucky to get to interview 3 amazing people from Google Cloud. 2 of them working for marketing. That's the first interview we're going to have. And we're going to be talking about something pretty amazing. If you've watched the keynote, you might have noticed that Urs was wearing some really cool earring.
So at least we know that he is always Urs because he has the chip. He is the real Urs.
Exactly. We're going to learn what that chip, what that earring is, and what the backstory behind it is. A very interesting one.
Yep.
And after that, we'll be talking to Miles Ward, who is an all-around great guy. He's been doing cloud stuff for a very long time, and I'm just excited to talk to him no matter the topic. So
yeah, Miles is fantastic. He's the global head of solutions at Google Cloud, and always has fantastic stories about customers and engagements that he's had across the platform.
So we get to talk to Miles Ward later on, but for now, let's go talk about Urs earring with our friends from marketing.
Cool, let's do that.
We're now joined by 2 very, very important people here at Cloud Next.
Very important.
We have Cornelius Willis and Neil Mueller. How are you both doing?
Awesome.
Well, great, now that I know how important I am.
So for everybody else that does not know how important you are, why don't you tell us a little bit who you are, what do you do at Google?
So I'm Cornelius Willis, and I take care of product marketing for Google Cloud Platform, which means I get to work with amazing people like Neil.
So what about you, Neil?
My name's Neil, and I work on infrastructure product marketing at GCP, which means I get to work with Cornelius.
Cool. So we have you here specifically for something that happened during the keynote.
The chip.
Yeah, the chip. Which was pretty amazing. If you're listening to the podcast and you have not seen the keynote, I recommend go and watch it. At some point, Urs, I'm going to try to say his name. I think it's always a test. Urs Holze?
Urs
Holzle.
Ooh, nice.
I'm going to go with Urs for now on. So Urs showed that he was wearing an earring that was a chip that does authentication for stuff and machines in the cloud. What is that thing?
So that is the Titan authentication chip that goes on a whole bunch of Google hardware. Essentially, every piece of hardware in Google's infrastructure can be individually identified, and any service using it mutually authenticates to that hardware. And the Titan chip is one of the ways we accomplish that. And we were so excited to be able to actually reveal that. I mean, if we think about the product marketing's job for a Google Cloud Platform, it's to convince leadership to progressively expose more and more of Google innovation, even if we're a little uncomfortable with it. Yeah. And so this is a great example of when we were actually able to throw back the kimono on something that's really interesting and is really different from what other cloud platforms provide.
Yeah, I liked the joke that Urs did, which was since we have the Titan chip, this is an authentic Google Cloud Platform, Google Cloud Platform keynote. Like, we know for sure that it's him.
Well, and the thing, too, is I was a little worried when he removed it from his ear, because then he was no longer in a trusted, good state. We might have had to shut it down, which is what would have happened
he
to a process.
He could have been compromised at any moment.
Well, yeah, and then done, right?
Yeah.
That's it.
This has been deactivated.
Well, I mean, because everything in the environment is untrusted until proven trusted. And
let's talk about the chip. What exactly does the chip do?
Let's take a step back before we start getting into the nerdery of this security microprocessor.
Which is very exciting.
I'm just really excited by the nerdery.
Let's tell an analogy. So I bet there's more people in the audience that have seen the movie Inception than understand what a the security microprocessor is, which is what Titan is. So if you've seen the movie Inception,
And if you have not, you should go
which is
see
an
it.
incredible movie
Well,
about
you kind of have to see that in order to. If you haven't seen it, you have to stop listening to the podcast. I think.
probably right
I-
now.
That seems reasonable.
I'd say so, yeah.
Yeah.
Yeah. So Inception is all about this thing in philosophy called simulation theory, and it's the disconnection and the concern about there being a disconnection between your perception of reality and reality itself. That you might actually be living inside of somebody else's dream, somebody else's sim city, and it's not actually your own little life. That's exactly the concern that Google has with regard to our hardware and our software. We want to make sure that the relationship between our hardware and our software comes up in a way that we consider trusted, and that's why we have a security microprocessor that we call Titan that authenticates this relationship. Every time we push a new piece of BIOS, which is software located on the hardware, Titan authenticates that installation, and every single time that hardware boots up, some software that we've given it, it authenticates that boot up. And it allows us to have, like Cornelius said, authenticated service-to-service level communication between our hardware and our software, and also between our software and our software. It's really similar in theory to the stuff that we also have in our security keys that every Googler has on their computer. Insofar as we believe at Google that everything should have an identity. Our hardware has identity, our software has identity. We live in a constantly, a state that we consider always untrusted, and we verify the identity of everything all of the time. And that way, if anything in our infrastructure is deemed rogue, we can very quickly de-identify it and then carry on with business.
So I'm wondering, does that mean that every single one of those little chips has some secret built in there, like basically like YubiKeys? That's something that basically at any point you can decide which one is the one. It's like, that is not a good one, and you just stop trusting the machine or whatever piece of hardware you have?
Yeah, so how do you know that the Titan itself is the real Titan?
Yeah, like, because you have many of them, right? So where do you
Let's
store
go
those?
deeper, right?
It startles all the way down.
So we fuse each individual Titan chip with a unique identifier, and this doesn't mean the writing that was on the top. Although we did remove that when we gave it to Urs and let him make an earring out of it.
It wasn't good on the jewelry anyway. It didn't.
No, it's that of style.
It
And
was
we were
gauche.
competing with a diamond stud to get him to
that's
wear
right.
it. So it had to, little numbers now.
The fusing happens inside the read-only memory of the chip itself, and it's done in such a way, it's done sequentially so that we can tell that it's a Titan chip that's in our inventory sequence. And it's done, and theoretically is only being able to be written once and can't be changed within the chip during the chip's entire lifetime. So you know that is the real McCoy.
And just to be clear, so we make the chips, right?
Yeah, a lot of our stuff, we control the design and the manufacture of that so that we are able to ensure to the greatest degree possible it has not been tampered with en route.
This is one of the big differentiators of our cloud versus every other cloud that I've been able to learn anything about. There are other folks that run data centers and other clouds as well, and they can buy servers that have security microprocessors on them. The majority of those that I've talked to don't use those security microprocessors. In fact, no cloud that I've been able to talk to uses their security microprocessors that are given to them by other vendors. Not only do we use those, but we created our own because it's not our jam to not understand fully the supply chain.
Yeah.
And so we purpose build our servers and our chips and our security microprocessors and our racks and our network controllers, as you saw in the picture when Urs was up on stage. We want to fully understand the supply chain so that we can guarantee provenance over the security of our cloud.
So it's not just identity that we're trying to authenticate, but also heritage. Where did that thing come from? Provenance.
Provenance.
Yeah, and it
Provenance.
sounds like it's like the whole thing too, from BIOS all the way through to software. Is
Yeah.
this doing the thing we think it's meant to be doing? And if it's not, there's a
And,
problem.
and perpetually challenge that across the entire system.
So to go back a little bit and get a little bit away from the geekness area, we'll be back there in a minute.
No,
Who had the idea of saying, "Oh, let's put a chip on Urs's ear"?
so Urs saw the little chips. Neil, first of all, somehow convinced someone to give him some of these chips. And so, Neil is a very robust guy. So I don't know what happened to that person. But we got the chips. And so Neil showed them to Urs, and they're these very cute little things. And Urs said, "Ooh, that could be an earring." And then he looked at me a few minutes later and said, "No, don't do that. No, don't do
He
that."
knew where it was coming.
And Neil, in the meantime, had gone off and found I don't know where you found earrings. Did you go to,
One of our product managers, Maya, knew of a craft store nearby, and I hustled over there
It's how the best things happen.
And so you got both the earring posts and the super glue at the same store.
Same place, yeah.
Wow.
Very useful.
Very efficient. And so he came back with the studs and convinced him that it would be something that would really get his picture in a lot of places.
And could potentially glue his ear together with super glue.
Yeah. And the thing that I think we were excited about is figuring out how to actually map this down into Urz's own sort of, immune system. So just the same way we have an immune system for our cloud, maybe you could figure out how to make that connection.
I'm a little sad, actually. I tried to put it through my ear. I had my ear pierced when I was probably like 15 or so, and the hole's slightly closed over, so I couldn't put it in properly. And then I was like,
well, maybe it's because you're not authenticatable.
No. You know what? Maybe it's the one.
Need to press
well,
harder.
I'm not Urs, and it's going, well, I don't know who you are, so we're not doing this thing.
Right.
Yeah.
So going back to the geekness area, I'm curious. So this is a very useful thing to have, right? The fact that you're able to authenticate a piece of hardware, it is amazing for us, Google, but it might also be amazing for other people everywhere in the world, right? Is this something that is offered as a service, or is just like a security layer that is internal to Google?
So right now, we're the only cloud that we know of that's currently using a security microprocessor. Not only are we the only one using one, period, but we're the only one that has purpose-built one. If we were to make this chip addressable for customers, configurable for customers, we would be the first cloud to do so. We don't currently do that.
Okay.
No, that's fair enough. I think this is also super interesting, right? The whole question of the cloud, and this often comes up where it's like, hey, is the cloud secure? Right? And we get that sort of thing like, oh God, we can't move things to the cloud.
This is one of those great examples of, oh my gosh, what did Eric Schmidt say on stage? He was like,
he said,
go to the cloud now.
Yeah, and don't try to do this yourself. It's a waste of your money compared to what we've been able to do.
But it seems like this is the sort of thing where you're like, is this the type of security you would do yourself if you're building stuff on your own, like data centers, your own networks? How much effort do you want to put in yourself? Like, I mean, this must have been a huge investment to make this thing sort of
well, and
happen.
a huge investment not only in money but in time.
Yeah, research.
Right? Many, many, many years of building out the layered architecture, and it hasn't stopped. Continue to do that.
So you might be curious what goes into a security microprocessor like Titan. So within Titan are three things: a random number generator, a crypto engine, and a monotonic counter. Of those three, the one that I really didn't understand until I Googled it was monotonic counter. And now that I learned what it means, I'm super excited to share. So a monotonic counter is essentially something that protects against replay attacks, in addition to other threat vectors. And it ensures that a count goes forward and never backward.
Yep.
So it's a tool within logs to make tamper evident. Because if you were ever to remove a log and say, oop, that never happened, that person never came here, it would be obvious because it would go from 2 to 4 to 5. It'd be obvious that you'd removed something. And if you tried to insert something and say something happened when it actually didn't, the monotonic counter would be proof positive that it had not occurred. So those are the three things inside a secure microprocessor.
Cool. So we said what goes inside of Titan, talked about what is used for. Where does it actually go other than on ears?
Yeah, sure. So the position is very important for this particular product. It needs to sit between ROM and RAM in order to provide a signature validation of the first 8 kilobits of installation of a BIOS, for example, or the boot up of any of our pieces of hardware. And once it validates the first 8 kilobytes of installation, it lets you install the rest of the BIOS and every machine boot. Cool.
So one last question. Is this something we're going to start creating a fashion line on it? Are people starting to use it? Do you see people in Mountain View walking around with chips on their heads? Which would not surprise me, to be honest.
No.
So, yeah, we're going to be making these. The Titan chip is comprised of an outer case and an inner microprocessor. We're removing the inner microprocessor, and then we're going to be attaching the exterior cake to cufflinks, earrings, and tie clips. And you'll see them.
I'm so in.
You're so looking forward to that.
You'll see them at the next.
I am so in.
There's an amazing pun.
Excellent. Well, I think that's about it. Is there anything else either of you would like to add, or anything that hasn't been mentioned that you think is important?
Thank you to you guys for doing this podcast day in, day out, the tireless work and creativity that you provide. And thanks to our listeners for being on Google Cloud Platform, being interested in what we're doing.
Thank you, YouTube, for taking the time to come talk to us today.
So Titan is super, super cool. Thanks to Cornelius and Neil for coming by and giving us a good long chat about that.
And thanks for bringing one of them. It was really cool to play with it.
We got to touch one. It was so cool. But why don't we head on over and talk to our dear friend Miles, whose effervescent energy brings everything to life.
Sounds good. Let's do that.
Amazingly excited and delighted to be joined by Miles Ward, Global Head of Solutions at Google Cloud. Thank you so much for joining us, Miles.
Thank you. I'm just super excited to be here. What an incredible week.
It's an amazing pleasure for me to have you here. I used to listen to your voice long time ago on that AWS podcast long time ago.
That's exactly right.
So it is amazing to have you here at the GCP podcast now.
It's just, the changing of the seasons. We
Yep.
move from the sort of cold winter of one cloud to the bright spring of another.
Ooh, I like the metaphor.
Such a beautiful and poetical way of putting it.
Yeah. Before we talk to you about Next and stuff, can you tell us a bit about what you do at Google?
Absolutely. So we have customers. That's
Hopefully.
Good. That's good.
lifeblood of any cloud, right? Like cloud technology is incredible stuff, but it really doesn't do anything until it meets the road with customer demand and actual usage in the field. So my team engages with customers as they've gone through working with our salespeople, our customer engineers that are kind of the first line of technical defense, and then they have escalation points like folks that are in specialist roles and in sales. But when everybody gives up, when everybody goes, that's too technical and scary and I'm not sure how we would build that, the solutions architecture team is the top point of escalation there. So I run that team globally.
You are also the team that is responsible for all the amazing white papers that we have available, right?
Yeah, we think of it as a very virtuous cycle, right? We go out to customers that all of our folks have told us, we don't know how to do this. We try to figure out how to do it. If we're successful, and we aren't always, but most of the time we are, if we can figure out how to make something work, we write it down. Because we are easily bored. We don't like doing things 3 or 4 times in a row. So we write it down, we publish it. That's all the material that's at cloud.google.com/solutions. And that stuff, our best practices or step-by-step instructions on how to move an application to the cloud or how to back up an application or how to build it for scale or set up for IoT or do work in media and entertainment and oil and gas and all over the place. So that kind of guidance, one, gets us out of doing the same thing twice, but helps us stay focused on what's next for customers.
And also, now that no one is listening, helps us here at the podcast because we might have been used some of those solutions as the main script for our podcast episodes. So thank you very much for those ones.
Hey, we are here to help.
Definitely, yeah. Then they show up, we're like, oh, good. Cool thing of the week. Done.
There you go.
New solution.
Well, it's one of the things that's exciting for me, right? I mean, any team has to grow. You can't just install a 200-person team out of thin air. And so we've been growing very rapidly. And what it allows us to do is ship more of this stuff, right? So we've gone from, 12 of them 2 years ago to 70 of them last year to I think we're going to take a goal for 100 of them getting shipped this year.
That is crazy.
On top of that. So it's really, and we watch, I can see the statistics of visitors coming in and downloading this material, and then I can see they go over and we see new accounts that follow these patterns. That's real business growing on top of us and reduced risk, right? I hate doing stuff from scratch if I don't know what it is that I'm doing, when I'm not involved in some kind of creative process. If I'm just trying to get something done and there aren't instructions, it's super obnoxious, right? and so when we talk to customers, every single one says, I just want you to tell me how I'm supposed to do it. And so we're trying to do that.
Yeah, and it's so much better to learn from the mistakes of others than doing it yourself.
That's right. And I think we have an environment that really radically de-risks that kind of experimentation. I think it's a fun place to build new things and to try stuff out. But I think some people have a certain amount of budget and a certain amount of time and focus for that kind of experimentation. Yeah. And then the rest of the time is spent on the obnoxious stuff that should just work. We're trying to go through and step by step walk through each of those pieces and make it so that they just work, right? Backing up a database is not something that is a creative and advanced expression of your
I do that on the weekends. So much fun.
So, it should probably have a manual.
Yep.
Yeah. Now, you speak to a lot of customers, and you've been here at Cloud Next. How have the experiences for the people you've talked to been like? What has been the response you've had to the venue and the event?
So, I think there's a couple of phrases that have come out of our keynotes and come out of some of our big presentations that have had a really big impact on the perspective from the customers that I talked with. I mean, I went to 3 different customer dinners just last night. So
Did you eat dinner 3 times?
well, you can have a lot of salad, and everybody sort of thinks that you're participating in the fullness of the chow. So what I heard from customers was sort of 3 basic things. First was from the first keynote, seeing HSBC on stage. That's an account that I did a lot of work with. I'm super excited to see them take the stage. Seeing how clearly for them that the value of cloud was associated with the speed with which they could do things. Like what they're seeing in every one of the examples and demonstrations is, man, this stuff is fast. It's not fast like 100 million IOPS or something like that. It's fast like it takes Evernote 3 months to move. It takes Lush a month to move. It takes Ocado 6 hours to rewrite their ETL, right? Like these statistics are really material to go, wait a minute. I'm planning and budgeting in the back of my mind on like Netflix scales where it's going to take 7 years to migrate. If I can do this stuff in months instead of years, the economics are totally different. The value proposition is totally different. And that's, as I go around enterprise to enterprise, even little startups that are already implemented in other places, they say, wow, I didn't realize that it was that much faster. That's a big deal to me. That really changes my perspective. So that's awesome. That's super awesome to see.
Nice. There's something to be said there about like the also the exponential growth that you can have, like Pokemon Go, Niantic. Yeah. So yeah.
Well, talk about exponential growth. So I was at the GCP event. They didn't call them next yet. 3 years ago.
Oh yeah, I remember those.
375 people there. I went to the one last year, presented a bunch, built a bunch of stuff there, built the treehouse over there for that.
Oh yeah.
There are 2,600 people that came through the door for that. There are like almost 14,000 people here.
It is crazy.
Right? I mean, it's 10x and then 5x. So say, okay, fine, 3x. We're going to have to put in intermediary floors inside of Moscone to be able to fit enough humans to watch all the stuff that we're building up. I mean, that's outrageous growth. Outrageous growth.
It is pretty amazing. Also seeing all the number of all the partners that we have all around. It is amazing. Yeah.
Yeah. Even just walking through the startup space, there's like 10, 15 of them in there, just all of them doing each individual cool things.
So, what other things have you heard from customers that were really excited about? Like, was there any specific announcement or something like that were like, oh, that thing was amazing?
So, I was surprised. I know the degree to which we hold it as sort of its own unique, class of thing, but. The messaging around Spanner has landed.
Yeah.
Right?
Nice.
And when I talk to customers, they go, look, man, I read that paper 5 years ago. I know that you guys had the crown jewels hiding someplace. I know that that's the one. We are diving in, figuring it out. And I'm watching on the inside as we work with customers and look at the metrics. I mean, the growth on Spanner adoption in weeks is stupefying, right? Like I've got engineers on the SRE team changing trajectory of focus to deploy more and more infrastructure into the Spanner hosting just to be able to keep pace with demand. And as our customers are talking about it, they look at, I think they got the message up front about the idea of, I can do globally consistent transactions. I can make it so that when I write something on one side of the planet, on the other side of the planet, I'm not messed up and out of sync. But I don't think they really realized that came along with super fast, super big, right? Like the simpler message of, millions of IOPS is okay. Doing it at gazillions of bytes. You can put terabytes in there is fine. Petabytes in there is fine.
Whatever.
Like, they're like, oh, I get both? Wait a minute, how am I, what? Like, it seems very surprising to them. So it's cool that we've been able to, really hammer on both of those messages. And I'm seeing businesses saying like, it's weird. You're right. I don't like my Oracle, and I'm not super stoked about my MySQL. And all of those are sort of a pain in the neck. Like, maybe I should try this out.
So, what's your point of view on the fact that Spanner is still beta? Does that mean that people are not using it? It seems like it's pretty much the other way around.
No, I mean, in my experience, what I've seen, you have to imagine there's a range of products that are being built by Google Cloud Platform that are being built for cloud right now as we speak, built from scratch, right? The DLP API is not that way. We take a service from G Suite and we externalize it as a dedicated service that customers can use, right? Spanner is an example that's more that way, where we have a running production system handling millions and millions of transactions a second, serving hundreds of Google businesses. It is highly mature in its operations model. Our SLOs are well defined. We have a clear standard of service there. the new part is that we're charging for it. So you have this little billing component that's got to get slapped on. You got to have an API that's externalized that you can slap on. And we need to test those to the same level of rigor as the core operations. I think in the database world, for me, the big risk or the big terror is losing data or having data corrupted. And I think those are the places where the new layers that are a part of Spanner to make it something that can be a public service, they just don't affect that part at all. So I see customers able to do that calculus and say, well, yeah, let's dive in. Let's figure that out.
Since you're on the customer side, now I'm just curious, are you seeing customers as they jump in on the beta being able to kind of provide feedback and push the direction of like where the product goes?
Yeah, so I had a great conversation on Twitter yesterday. One of the parts of the design of the product, in order to be able to meet the tight SLOs that it's designed for, to be able to deliver the kind of transactional consistency, it's not multi-tenant. So we ask you to build individual nodes, which we call on our side, and like any good relational structure that's replicated, your real default there is to deploy 3 nodes. So the minimum cost to run it 24/7 with those 3 base nodes, putting lots of gigabytes of data in there, it's about $2,000 a month. So when I talk to developers, they say, look, when I'm in prod, I'm going to give you $200,000 a month because I'm going to want to run this at the size of the moon. But right now I want to mess around on my laptop, and I want to mess around in a way that I know is compatible with the primary thing. Or fine, if it's impossible to put on my laptop, give me something that I can run on a micro or whatever, so that it's at a price point that's compatible. And I know our product managers, they made an analysis of the market and they're looking what technology they have available. I think we were really eager to take what we know of as the exact best practice for a product that already has a reputation years before it's launched, and make sure that that product behaves exactly the way customers have dreamed about for years. Now they've got their hands on the real deal. I think the feedback that I've heard is clear enough that it's obvious to me that we'll go through and do the work to create something that's designed for developer consumption so that the experimentation can happen without costing a couple grand.
Nice. Is there anything else that you think our audience would like to know? Like any anecdote, anything that might have happened backstage that you'd like to share?
Sure. So I'll tell you one that's funny. So Chris Sells, who's the product manager building all the stuff for Windows, right? He's the guy who did the car crash on stage with the Hot Wheels.
Oh yeah,
right. Like that I think is hysterical, right? Like he's like, oh, we need to do this sort of at a different scale, and he brings out these cars. He actually makes the crash noise and everything. So what he told me was that he really had to kind of go through and think hard about, which Hot Wheels would he bring on stage. like these are going to be famous Hot Wheel cars.
Yeah,
right? Like, they're going to take some video cycle. So he sort of had to pick through his kid's box and find just the 2 coolest trucks that he had.
I think that we have amazing speakers, and they do the weirdest things. We also saw this morning Justin Beckwith with the durian. Yeah, taking it to stage.
Just cause.
I don't know what's happened there, but yeah, that is pretty amazing.
Unbelievable.
All right, Miles. Well, thanks for taking the time. Come hang out with us at the podcast. We really appreciate you telling all the stories. And hey, man, you ever want to come back again, we'd be more than pleasure to have you.
Hey, you guys are doing outrageously great work. I work every day and take benefit from the awareness that you create, so I super appreciate it, and I'd love to come back.
In exchange, next time you come, you need to play the tuba.
I will totally play.
You have a tuba?
Yeah.
That's happening.
Oh yeah, there's backstory there.
Fantastic.
Thank you so much.
Thanks, gents. Bye.
So thanks again, Miles, for such an interesting conversation. I've met him long time ago. Like, first time I heard his name was long time ago on the AWS podcast. Last time I saw him was somewhere in Japan. He was giving talks all around the world. He's a super cool guy. So thanks so much for taking the time to talk to us. It is sad, but
it's over.
This is the end.
This is the end. Well, at least till next week.
Yeah, till next week. This is the end of Cloud Next 2017. It was an amazing conference.
Yep.
And we didn't want to finish the episode, the 4th episode in this week, without saying a huge thanks to our dear editors.
Yep. Sean, James, thank you so much for putting up with this, doing daily episodes, editing all our podcasts.
You're amazing.
Yeah. To everyone who's listening, huge thanks to them because they do an amazing, amazing job.
Yeah, especially because maybe you cannot tell, but we're incredibly tired, so we actually keep on messing it up, and they need to edit it up back to making it sound almost normal. So thank you again. Thank you so much.
And Francesc, thank you to you for being so wonderful here as well today.
Thank you, Mark, for being here on your birthday. Happy birthday.
Yes, and thanks to everyone who came past the booth, said hello, grabbed some stickers, grabbed some t-shirts, even just wandered up and were just like, hey, we love the podcast.
It was awesome. Thank you all so much. We really felt the love.
Yeah, and thanks to everyone who listens.
And talk to you all next week.
See you all next week.